So this video lecture is for the lecture on Monday. And in this lecture, we're going to start a new topic. This is lecture number 4, Manufacturing Systems. And the material covered in this lecture is part of the chapter 8 of your textbook. In this lecture, we're going to cover half of the slides that we provided for the lecture. In particular, we're going to talk about fixed automation systems and flexible manufacturing systems, and how do they relate to facilities planning. So as always, I present the course objectives just to give you an idea of what are the things, or to remind you what are the things that you need to remember once you're done with this class. What are the most important things that you need to learn. So the agenda for today, again, we're going to cover the first 3 topics of this outline, including the introduction, fixed automation systems, and flexible manufacturing systems. The objectives for this lecture is to understand the several types of manufacturing systems as they relate to facilities planning. So we're going to talk of 2 of them in particular, the fixed automation systems and flexible manufacturing systems. So in terms of the introduction to this subject, efficiency of the manufacturing activities will make a major contribution to the firm's short and long-term economic profitability. So this is something very important when you're planning these activities. You know that you need to plan them efficiently, so in the long run you have the best economic benefit from it. So the effectiveness of the facility layout and material handling in this facility will be influenced by a number of factors, including change in product mix and design, materials and processing technology, handling, storage, and control technology, production volumes, schedules, and routings, and finally, the management philosophies. So again, the effectiveness of the facility layout and material handling in these facilities is influenced by a lot of things, including the one listed in this slide. Many external factors affect the facility planning process. Among these factors, some of the ones that have a significant impact include the volume of production, the variety production, meaning you have multiple types of products, and the value of each product. Each of these factors may lead to a different type of manufacturing facility, and we discussed that in class. For instance, you can have a production line, cellular manufacturing, or a job shop. So now that we know that type of manufacturing system that you can have will affect not only the manufacturing system, but other things will affect the facility planning for your department or facility. Now let's differentiate between different type of manufacturing systems. So we're going to start talking about a fixed automation system. And in this figure, I'm showing you a fixed automation system that is used to make continuous linear welds. And it uses a track system along which power saw, welding wire, and automated arm travel. So we can see that arm in that figure, and also we can see the track system. So in this slide, the figure that is shown is basically another perspective of the same type of fixed automation system. So again, we're going to have a rail that is going to be moving some of the things that are needed in this type of manufacturing system. So in the transport line, which is a fixed automation system, materials flow from one workstation to the next in a sequential manner. Now, the production rate for the line is governed by the slowest operation. So that operation is the one that is going to keep the pace of your process. And transport lines are often used for high volume production, and these are very highly automated. Some of the disadvantages of a transfer line: the very high equipment costs. So most of the processes are automated, so they are performed by machines. So you can imagine having to buy the equipment might end up having a very high, very technological equipment end up having a very high cost. Inflexibility in the number of products manufactured. So these are fixed lines, so they don't have a lot of flexibility. That's also affecting the layout. Large deviation in production rates in case of equipment failure in the line. So as these processes are sequential, so you need all the machines to be ready to complete the process. So if one of them fail, then you can imagine that you cannot complete the production that you are expecting, because that machine will not allow you to do it. So the design of transfer lines includes both the specification of the individual processing stages and the linkage of the stages. The facilities planning. For the transfer line is straightforward. The processing equipment is arranged accordingly, according to the processing sequence. And as a result of the predictable flow sequences, straight line flow and derivative of straight line flow are frequently used. So on the next slide, we're going to show you some of the variations or several variations of the straight line flow structure. So we have at the top on the left, we have the straight line flow, which is basically a straight line with stations arranged in a sequence. Then we have the U flow, which is also sequential, but in these cases you might want to have the input and the output on the same area of the facility. And then we also have a circular flow, which is also sequential and also gives you the input and the output on the same place. A second type of automation system or fixed automation system is called dial indexing machine. One particular implementation of the circular flow is this one. So the dial indexing machine. And this is a particular example of the circular flow. In this one, parts go from one machine to another without manual intervention, meaning that you're going to have some type of material handling equipment moving the parts from one station to the other. So materials are transferred from one machine to the next in a sequence by an automated material handling system. And some of the examples include, for this type of manufacturing environment or system, automated systems for automotive parts, chemical processes, beverage bottling, heat treatment processes, and steel fabrication. And in this figure we show, in this picture we show one type of indexing machine. And as you can see, here's a table that is moving, that is used to move the materials around from station to station. Now let's move to a different type of manufacturing system. This is called flexible manufacturing systems. So, term flexible basically stands for you have more flexibility. So that's what we want to achieve with this type of manufacturing system. In the flexible manufacturing system, you are able to manufacture a large number of different part types. And the components of a flexible manufacturing system are the processing equipment, the material handling equipment, In the computer control system. And the computer control system or equipment is used to track the parts and manage the overall flexible manufacturing system. So this is what is tracking the processes, the number of parts that you're processing, and so on. Some of the examples or situations for which a flexible manufacturing system may be appropriate include production of families of work parts, random launching of work parts onto the system, reduce manufacturing lead time, to increase machine utilization, to reduce direct and indirect labor, and better management control. The following design requirements are recommended in designing material handling systems for flexible manufacturing system. First, random independent movement of palletized parts between workstations. Second, temporary storage or banking of parts. Third, convenient access for loading and unloading. Compatibility with computer control. Provision for future expansion. Adherence to all applicable industrial codes. And finally, access to machine tools. Flexible manufacturing systems are designed for small batch, low volume, and high variety conditions. So a batch is a group of production items. You're going to group them and you're going to move them as a batch. So this type of manufacturing system is for low volume and high variety conditions. And because of the variety of alternatives, storing, handling, and controlling material, because of the varieties of alternatives for these three things, the specification of the material handling system and design of the layout can be quite varied. So in the next few slides, I have some examples of different type of flexible manufacturing layouts. So on the first one, this is a flexible manufacturing system with centralized layout. And the important thing here, you have this U shape. You have your machines 1 through 6. There you have some access to this transporter, AGV transporter, which stands for automated guided vehicle. So you're going to have this automated guided vehicle taking your parts to each one of these manufacturing cells. And then you have a centralized storage system. So from the storage, you're going to move using this automatic vehicle from cell to cell. And then when you are done, sometimes you need to visit all the cells to complete the product, but sometimes you need to visit only some of them. Or for instance, here you have an access to the manufacturing cell, so that means that you might need to return to one of those cells to get the the process completed, and finally you take back the part or the product to the centralized storage system. So this is a very highly automatic manufacturing system. Here we have a different type of setup, and this is called flexible manufacturing system with internal centralized layout. So in this one we have a pallet storage in the center of the layout, and we have this material handling system moving the parts from station to station. So this one shows an internal centralized working process storage. WIP. So working process means that you are working on that part, but you are not done. So once if this part is still in the manufacturing area, then you need to count it as a working process. Once the part is completed, then you know it's out of the system. So that will become a completed product. So working process is needed because a part has to go through several machines before it eventually leaves the system after the last machine operation is performed. So in this type of layout, we have a centralized pallet storage, so we can move the working process to these areas and take them also to the different manufacturing cells. Another flexible manufacturing configuration is based on cellular manufacturing principles, and we talked about this in class already. And basically, the handling distances are reduced significantly as the machines are placed within the work envelope of the transfer device. So most of the time, this is a robot. And we have one of those robots here in the School of Engineering. Um, so if you're interested, I can take you to show you one of those robots. But here we also have a video that I want to show you so you can have a better idea of how does that work. So let me see if you can get access to the internet. So our robot is gonna bring one of the parts from one of the stations and is gonna take it inside this machine. So sometimes these are very expensive parts that you need to handle very carefully. So you'll see the robot take the part and it will transfer it from one station to the next one. And once the part is placed on that machine, then the robot will get another instruction to see where it needs to go and if it needs to transfer any other part to another machine. So the processing completed, it takes the same part and it return it back to the original station. Okay, so that's a flexible manufacturing system with a robot handling system in a cell manufacturing environment. So what makes flexible manufacturing or flexible manufacturing systems flexible? Must have the capacity to do the following. Must be able to process different part styles in a non-batch mode. You must be able to accept changes in production schedule, respond gracefully to equipment malfunction, and breakdowns in the system, and accommodate the introduction of new part designs. Okay, so this is the end of this part of the lecture. I'm going to continue with this lecture on Wednesday, and on Wednesday we're also going to have our review for the exam. So our first exam is going to be on Monday of the next week, Monday, September 29th. So this coming Monday, I'm going to be out of the city, so that's why you're going to have to watch the lecture using this video. On Wednesday, we're going to have our review, and you have a homework due on Wednesday, and then on the Monday after that, we're going to have our first exam. So please let me know if you have any questions, and I'll see you next week.